Welcome to The Explainer. Today, we're diving into a really fundamental topic in your software engineering journey, and that's section 3.1, Agile Methods. Whether you're going to be building a small mobile app or some massive enterprise system, understanding formalized software development methodologies is absolutely crucial for your career as an engineer. As we've seen in earlier parts of this course, failing to use proper engineering methods is honestly one of the main reasons why software projects end up being way too expensive, totally unreliable, and delivered incredibly late. So today, we're looking at a methodology that completely revolutionized how the entire industry built software.
To keep things nice and clear, here's our roadmap for this session. 1. The plan-driven era. 2. The problem with plan-driven. 3. The Agile Manifesto. 4. 5 principles of Agile. 5. Where Agile succeeds. And 6. We'll wrap up with the summary and exam focus. All right, let's jump right in. Section 1. The plan-driven era. The history of heavyweight software engineering. Okay, let's dive into this. To really get why Agile is such a big deal, we first need to paint a vivid picture of what the software engineering landscape looked like back in the 1980s and early 1990s. Back then, there was this widespread belief that the only way to get better software was through highly controlled, rigorous processes. This era was completely dominated by what we call the plan-driven process. So let's define that clearly. A plan-driven process is a software process where literally all activities are planned out in advance. It relies incredibly heavily on formalized quality assurance and creating really rigorous, comprehensive documentation before a single line of code is ever written. It's a very heavyweight approach where progress is just constantly measured against this one master plan. Now, you might be wondering, why on earth did the industry work this way? Well, it was absolutely necessary for the types of systems they were building at the time. Think of massive aerospace control systems or critical government infrastructure. These projects were built by geographically dispersed teams across totally different companies, and they could take up to 10 years. Yes, a full decade, from the initial specification to the actual deployment. When you're building a spacecraft, that massive overhead of planning and documenting is for sure entirely justified. But as we moved into the late 1990s, this widespread dissatisfaction began to simmer, which eventually led to the birth of rapid software development. That brings us to Section 2, the problem with plan-driven, or when heavyweight fails for business. The reality was the business world was simply moving way too fast for decade-long development cycles, bringing everything to a breaking point. To understand this failure, we've got to define a really critical concept here, and that is overhead. In software engineering, overhead refers to the excessive time and resources spent on planning, designing, and documenting a system rather than actually programming and testing it. For small and medium-sized businesses, this overhead became a massive roadblock. And this comparison brilliantly illustrates the divide. On one side, massive aerospace systems absolutely justify that heavyweight overhead because their requirements stay pretty stable over long periods of time. But on the other side, in small to medium business systems, the overhead completely dominates the whole process. More time is spent deciding how to build the software than actually building it. The fatal flaw was that business requirements changed so rapidly. By the time a plan-driven software system was finally delivered to a business years later, the original reason they even asked for it had often changed so much that the software was effectively useless. Massive, expensive rework was required. So, ultimately, the fatal flaw of the plan-driven era was its total inability to adapt to a fast-moving reality. Which leads us perfectly into Section 3, the Agile Manifesto. The late 1990s shift. The industry desperately needed a way to deliver working software quickly, and this sparked a massive cultural shift. In 2001, a group of leading software developers gathered together and published a philosophical statement that changed, well, everything. It begins, "We are uncovering better ways of developing software by doing it and helping others do it." That single sentence really set the stage for a new era where the focus shifted back to the actual software itself. Okay, definitely write this down in your notes because it is foundational. The Agile Manifesto is built on 4 core values. The author stated that while there is value in the items on the right, they value the items on the left more. Number 1, individuals and interactions over processes and tools. Number 2, working software over comprehensive documentation. Number 3, customer collaboration over contract negotiation. And number 4, responding to change over following a plan. These 4 values represent a total rejection of that old, rigid, plan-driven mindset we just talked about. So to briefly recap this part, the Agile Manifesto completely flipped our priorities from rigid, heavily documented plans to flexible, collaborative software creation. Moving on to Section 4, 5 Principles of Agile.
Let's break down figure 3.2 from your textbook.
I really want you to pay close attention as we unpack this. While there are plenty of specific Agile methods out there, like Scrum or extreme programming, they all share the fundamental principles found in figure 3.2. The first principle is customer involvement. In Agile, the customer isn't just someone who signs a contract at the beginning and then magically receives a product at the end. No, they are an active, continuous participant in the development team. Their role is to constantly prioritize new system requirements and evaluate the software as it's actually being built. The second principle is embrace change. Now, there's a very common misconception here that students make. Agile does not mean no design. Actually, scratch that. It's more like it means expecting that system requirements will inevitably change and actively designing the architecture of the system specifically so it can accommodate those changes without breaking the whole thing.
The third principle is incremental delivery. To translate this into plain English, we build a little, we test a little, and we deliver a little. Instead of waiting 3 long years for a massive final product, the software is developed in manageable chunks. The customer looks at what they have right now and then specifies the requirements for the very next increment. It's a game changer. Principle 4 is maintain simplicity. This is absolutely crucial because it applies to 2 different things. First, keep the actual code you're writing as simple as possible to meet the current requirements. Don't over-engineer it. Second, keep the management process simple. If a piece of documentation has dubious long-term value, just actively eliminate it.
And the fifth and final shared principle is people, not process. This is all about empowering the developers. It shifts the power away from rigid management rules and actually respects the talent building the software. You trust the skills of your development team and allow them to self-organize and figure out their own best ways of working. So let's quickly recap this major section. You involve the customer, embrace change, deliver in increments, maintain simplicity, and trust your people.
Right. On to section 5, where Agile succeeds. Let's look at the ideal environments. Now that we've got the theory down, we have to look at reality, because Agile isn't a magic bullet for every single project out there. What's really interesting about this slide is that it highlights the 2 specific environments where Agile is incredibly successful. First, product or app development. If a company is building a small or medium-sized product for sale, like, say, a mobile app, virtually all of them use Agile today. Second, internal custom system development within an organization, but only where there's a really clear commitment from the customer to be involved. Why does it work so well here? Because these environments usually allow for co-located teams, meaning everyone is literally in the same room, allowing for continuous, informal communication. Furthermore, these are usually standalone systems, meaning you don't have the massive overhead of coordinating with dozens of other external engineering teams. So to summarize this topic, Agile succeeds best in co-located, standalone product and internal custom system development, where communication is constant and direct.
Finally, section 6, summary and exam focus, what you absolutely must memorize.
Okay, let's reel our attention back in and focus on exactly what you need to take away from this lecture for your exams. If you see a test question like this, why would a team choose Agile over a plan-driven approach for a new web application? Your mind should immediately jump to the differences in the business environment. The answer lies in the fact that a web application operates in a ridiculously fast-moving market. A plan-driven approach would create way too much overhead and just take too long. Agile is chosen here for its rapid delivery, its deliberate lowering of process overhead, and its inherent design to handle constantly changing requirements through incremental delivery. So, here is your final checklist to memorize. Ensure you can list and explain the 4 core values of the Agile Manifesto and the 5 shared principles of Agile methods. Most importantly, remember the grand narrative of this section. Agile's fundamentally shifted the industry's focus away from heavy, bureaucratic documentation and placed it squarely on delivering working software quickly to the customer. In our next explainer, we're going to build on this foundation and look at the specific, practical Agile development techniques, like extreme programming and Scrum, that engineers use to actually implement these principles day to day. Until then, ask yourself, in a world where technology literally changes overnight, is any long-term plan ever truly safe?